So, having understood why we need an equivalent circuit model, let's actually start building the model. So, in order to understand the model and build it, we need to actually identify what components we have. So, if we start first looking at the primary, we have a wire, and the wire is wound a number of times around the coil, around the magnetic core. Any wire will have resistance. So, the first step is actually to account for the electrical resistance of the primary. And we actually do that by simply drawing a resistance, and we will refer to this resistance as R subscript P from the primary. And we can do the same for the secondary. So the secondary is a wire, and the wire is wound around the magnetic core, so it will have resistance, and that resistance will appear in the secondary circuit, and we will denote it as R subscript S. So that's the first step. Let's actually do this to complete the circuit, and we will still have VP at this side, VS at this side. So that's actually the first step, and in fact RP and RS will actually account for the copper losses. So RP is the primary resistance, RS is the secondary resistance. Both of these, they account for the copper losses, and in some cases we refer to the copper losses as or I square R losses. The other thing we should notice about these, they are in series with the circuit. So we could actually think of these components and other components we're going to insert as series, because in effect they're connected in series in the circuit. The second component we need to take into consideration, we have to go back and look at these green lines, and this is the magnetic flux that is actually flowing. Flowing is actually, we use that in it's a figure of speech. Nothing is actually flowing. We have magnetic domains aligning themselves, but simply we refer to this as flux, which is flowing. What we note here, and you see these lines outside, not all of the flux that is actually passes through the primary links the secondary, and not all of flux that passes through the secondary would link the primary. So we refer to this flux as leakage flux, or magnetic flux. And leakage flux is actually the magnetic flux from the primary that does not link the secondary. And in order to account for this leakage flux, this is flux, it's a form of inefficiency. So this is actually a form of inefficiency. It's not a loss, it's not a true loss. There's no power loss caused by it, but it's a form of inefficiency. It actually, we've generated as much flux, magnetic flux, as we can, and in an ideal world we'd like all of that flux to link the secondary. Unfortunately, some of that flux leaks out. So there's leakage flux, and in order to account for the leakage flux, the best component to do that is actually an inductor. and we refer to this inductor as X subscript P, and we have the J symbol because this is the reactance of an inductor. Notice that we actually could have referred to this as LP, as an inductor. But in fact, we used reactance and we've referred to it as a reactance. And we know that actually we can transfer from one to the other. So we could simply say LP or XP. And we know that XP reactance is equal to omega LP. So we could actually convert from one to the other. That's not a problem. And in the same way, we have leakage flux that actually links the secondary and does not link the primary. And in order to account for this inefficiency or for this leakage flux, we do the same. So we actually have X subscript S with the J operator, and that actually, and we could have actually said LS in Henry's, but actually we've used XP and XS. So this is actually the first step. We've identified the series components. So we still haven't looked at any shunt components, we've just looked at series components, and the series components in this case are made up of a resistance. Remember that the resistance would generate actually a true loss in watts in the transformer, another series resistance at the secondary, and leakage flux, and we've represented those leakage fluxes as an inductor in the primary and an inductor in the secondary, but we've actually put it down as reactance rather than inductance.